Hello and welcome to this video out of my Networking Basics series. I'm Wolfgang Tremmel and I run the DE-CIX Academy. If you're interested in more videos, white papers or other downloadable content, just head over to the DE-CIX website and have a look. Today I'm talking about UDP, User Datagram Protocol. And this is now part 4 of my Networking Basics series. I started talking about networks in general, about Ethernet, about the IP protocol, and now I'm talking about the transport layer. Remember, the IP protocol has layers. So the IP layer, the internet layer, the one I talked about in my last video, that's responsible for source to destination transport. And it needs addresses for that. Protocols on the internet layer are IP version 4 and IP version 6. Today, let's move to the transport layer. The transport layer may provide flow control, reliability, and congestion avoidance. Examples for protocols on the transport layer are TCP and UDP, and it also may contain information about the next layer upwards. And with all these layers and this encapsulation, this is all like the Russian dolls. So we have a payload inside something, inside we have another payload. So IP packets have a payload, and this payload is usually UDP or TCP. And of course, the UDP and TCP part again has a payload, which is then part of an application. So we have a UDP packet inside an IP packet. If you remember what I said about the IP header, in this case the IP version 4 header, there is the protocol field, and the protocol field contains information about what type of protocol follows the IP header. In IP version 6 it is called next header and has the same meaning. So the value in the next header field can be, for example, TCP or UDP or anything else. We are starting with UDP today because that's the easiest of the transport layer protocols. UDP stands for User Datagram Protocol. Its protocol number is 17. That's the value inside the next header field then. And it was introduced in 1980. So it was not the very first transport protocol. TCP is older. Let's have a look at the UDP header. The UDP header looks very, very simple. It's just 4 fields, each of them 16 bits long. There is the length field. The length field contains the total length of the UDP header plus the UDP payload. So since the header has a fixed length, you can easily calculate the payload behind the UDP header. Then we have the checksum field. The checksum field is optional for IPv4 because the IPv4 header itself has a checksum field. It's required for IPv6. The IPv6 header, the IP header, has not a checksum field, so it goes into the UDP header then. And the checksum calculates over parts of the IP header plus the UDP header. Then we have these 2 port fields. There is source port, which is optional. If it's not used, it's set to 0. And we have destination port. And the term of a port number, that's something new for this video today. So what is a port number? Just imagine a UDP packet is like a letter and it's being delivered to a big apartment building. And of course, a big building, it just does not have only one post box where all letters go in. It has a post box for each apartment. And these apartments all have numbers. And the destination port number is like telling the postman to which apartment the UDP letter has to be delivered. Of course, in reality, we do not have a building. We have a computer system and we have software running on it. But we do have port numbers, and behind each of these port numbers there is a piece of software, a program which listens to incoming UDP packets. On some system this software is called a daemon, and if a UDP packet with a specific port number arrives, it is delivered to that piece of software sitting behind that port number. So, what's UDP used for? And why is UDP communication called connectionless? The sender doesn't know if and when the packet has arrived. So the sender just sends UDP packet. There may be an answer, but there may be not. If there is an answer, the sender knows the packet got through. But if there is no answer, either the packet got lost or the answer got lost. So UDP is used for types of communication where it doesn't matter if a packet gets lost or got through or the answer gets lost. So let's have a look at an example. One example is the network time protocol that's being used for synchronizing clocks over the internet. So systems send and receive packets with a timestamp in it. If one gets lost, well, there will be another one in just a half a second or even less. So it doesn't matter if anything gets lost if you're synchronizing the clocks. You just send enough packets and you can be sure enough of them are getting through. Another example is the domain name system. The domain name system is kind of the phone book of the internet. So roughly explained, a system asks for an IP address for a specific name. So like www.DE-CIX.net, please give me the IP address of that. And that's also via UDP. And if it gets lost, well, then you ask again. And if you ask 3 or 4 times and don't get an answer, then you say, okay, this website or this address isn't reachable, isn't resolvable. Last example, DHCP, that's the Dynamic Host Configuration Protocol, mainly used in IPv4. That's if you connect a computer to a new network and you need an IP address. DHCP takes care of that. You broadcast the request for an IP address. Broadcast means you set a destination IP address of 4 times 255, and one system on that local networks says, okay, I'm responsible for distributing IP addresses. It receives this UDP packet and sends back a UDP packet and tells you which IP address you can use and some more information about getting you up and running on an IPv4 network. Let's talk a little bit about network security. Well, like I said, UDP is connectionless. So a UDP packet is received by a system, it's delivered to the software matching the destination port number, and if that software needs to send a response, it simply uses the source IP address to send the response to. So the source IP address becomes the destination address of the response. Can you see a security problem in that? Let me show you how UDP connection usually works. Here we have a sender and we have a receiver. So we are sending a UDP packet from the sender to the receiver. And we get an answer. And as you see, the answer is quite bigger in terms of bytes, in terms of packet size than the request. So the attack scenario now looks like a sender sends a UDP request with a faked source address. and the receiver sends the answer back to the attack target, to the system which has the destination address of the faked source address. Well, you can see it with the colors. So a system gets a big packet which it hasn't requested. That doesn't look so bad here. But now imagine that you are doing that not with one target or with one relay, but with a lot of relays. So you're sending a lot of small packets with faked source addresses, with all the same faked source address, and all these packets are sent back to the attack target, which then really has a problem. A few real-world example where that happened. Memcache daemon. That was a software or is a software which caches objects in memory for fast retrieval. The attack method was tell an unsecured implementation of Memcache daemon, send me a large object with a faked source IP, and Memcache daemon send back an object with up to 51 times larger the response packet than the request packet. So we say we have an amplification factor of 51,000. The solution for resolving that was simple, just remove UDP from Memcache daemon. Of course, a lot of systems needed to be patched, and I guess there are still a lot of unpatched systems out there. Another example is again the network time protocol. And network time protocol had a debug command where you can say, send me a list of systems for the last 600 hosts you have talked to. Well, and if you hear 600 hosts, you already know that the list is a little bit larger. So also that was used to attack. So send a small packet with a faked source, get a list of 600 hosts back to the attack target. And the solution here again was to remove that debug command from the software. And again, here we have the problem that there are still a lot of unpatched systems out there. So, talking about UDP today. UDP stands for User Datagram Protocol. And it's a connectionless protocol on the transport layer. UDP packets are also called datagrams. The UDP header contains a source and a destination port number, and the source port number can be 0 unused. And if misconfigured, UDP can be used to attack networks. So if you are a software developer, make sure that this cannot happen to your software. And because of that, more and more services which relied on UDP, which were built on UDP, are now moved to TCP because TCP does not have these problems. And TCP, that's the topic of the next episode. Thanks for listening. I'm Wolfgang Tremmel. I run the DE-CIX Academy. See you next time. Bye bye.